Alright, so this is your study guide on scientific notation and direct and inverse variations. So our first question on here is about direct and inverse variation equations. This one says, what is the direct variation formula? You have to have this memorized by the time you get to your quiz and your test, and you will not have this on your SOL formula sheet either. So make sure you get this down. And that is y equals ax. So anytime you see direct variation or you see varies directly, that's the formula you need to be thinking of. And our next question says, what's the formula for the constant of variation in direct variation? So what it's asking for is over here in this A section right here, that A. What is the formula just to solve for that? And the answer is A equals y divided by x. Number 3 asks, what is always the y-intercept of a direct variation graph? Now you can put the number 0, or you can say the origin, because that's a key point of direct variations. When you graph them, they always go through the origin. Number 4 says, what's the inverse variation formula? And for that one, so inverse, that's y equals k over x. So anytime you see inverse variation or varies inversely, that's the formula you need to be thinking. Number 5, what's the formula for the constant of variation and inverse variation? And for direct variation, we called it A. For inverse variation, we call it K. So your constant there is K. And you solve for that as x times y. You can also think of that as y times x if that helps you. For number 6, we are told y varies inversely with x. So right away, I need to be thinking our inverse formula because it says varies inversely. So immediately when you see something like that, write y equals k over x. It says if y is 12 when x is 4, write the inverse variation equation. So that's part 1. Part 2 says then find y when x is 20. So we're going to first try to find a k to plug in here so that we have an equation. So our k formula, going back to right above that, k equals xy, we need to plug in that x and y that they gave us right here into that formula. So our k is equal to 4 times 12, which is 48. So take that k value, plug it into your base form, and you've got your equation, y equals 48 over x. That's part 1. Part 2 says, find y when x is 20. So we're going to use this equation we just found and kind of extend it a little bit here. So we're going to say y equals 48 divided by our new x value, 20. So decimals are okay. That is 2.4. For number 7, I see y varies directly. Do you see that right there? It's always going to say it, and it's always going to be in order. Only thing that might do to you is change your variables. So when I see varies directly, I should be thinking y equals ax right away. Same type of problem. We want the equation. And then it says, then find y when x is 20. So it's 2 parts. And our first part is find an a value here. So for direct variation, we need to find a with our formula that we found right above here, y divided by x. So I'm going to look at what they gave me. I'm going to take my y, divide it by my x, and say that my a is actually 3. So my answer over here for my formula, my equation, is 3x. So y equals 3x. Now let's use this and make an extension. So this one says, when x is 20, what is y? So use this, plug it in. 3 times 20 equals 60. So that would be your new y equals. Now number 8, I know a lot of students are struggling with questions like this. It says circle the equations that are direct variation, put a box around inverse variation, and cross out equations that are neither. So remember, we have 2 formulas that go with direct variation and 2 formulas that go with inverse variation. And the majority of the time, it's going to fit one of these 2 formulas. So for direct variation, we've got y equals ax, and we've got a equals y divided by x. For inverse variation, we have y equals k over x, and we have k equals x times y. So if it can match up to one of these formulas, we know it right away. Sometimes we have to do a little more work though. So let's see what we have. First one here says x times y equals 1. Well, notice that matches up really well with this one right here. We've just plugged in a number value for my k and kind of switched it what side it was on. But right there, that's inverse variation, and it says to put a box around inverse variation, so we're going to box that in. My next one just says y equals 10. That is neither, so we're going to cross it out. It's neither because there are no x's in there at all, so all of ours need a y and an x. What that really is a HOI, so that would be a horizontal line, so it wouldn't be a direct variation or an inverse. Number, well, it doesn't really have a number right here. 8x minus 4y equals 0. That's when it doesn't match any of our forms, but we can't automatically say that that is neither. We really need to move that around a little bit. We need to solve for that y right there. So let me move this 8x to the other side. When I switch the side, I'm going to switch the sign, so that's negative 8x on that side now. Then I'm going to get rid of my coefficient, so I'm going to divide by negative 4. And y equals 2x. Well, now that that's solved for y, I can tell that it's really direct variation. Another way you can tell this, so I'm going to circle it because it's direct variation. Another way that you can tell this, when it says equals 0 there, and it's only the x and the y on that side right there, that's always direct variation. And our last one right there, sorry about my dog. My last one right there says y over x. So I'm looking for a formula that says y over x, and I see it down there for direct variation. It's my A formula, so the constant variation formula, but I can go ahead and say that is direct variation, so I'm going to circle it. On the back side, I've got a nice little problem here. You've got one very similar to it on your notes. So if you need another example of this, please check out your notes. It's the last example on your direct and inverse notes. So I've been given a table, x and y values, and I'm going to select 3 points that are direct variation, and I want to select 3 points that are inverse variation. So if it's in direct variation, that should have the same a value. So all my a values should be equal. If it's an inverse variation, all my k values should be equal. So let's remember the formulas for a and k. A is y divided by x. K is x times y. So I'm going to set up a nice little table over here. Kind of extend the one that's already there. And in that first section, I'm going to test for direct variation by taking every y value and dividing by the x value. In my second section right there, I'm going to check for inverse variation. So I'm going to take every x and multiply by the y. So let me see what I have. First one right there, y divided by x, 6 divided by 3 is 2. My next one is 15 over 7, that's a decimal. So I'm going to leave it as a fraction for now. My next one says 12 divided by 6, so y divided by x. That's another 2. So right now I'm seeing 2 a values of 2. So let me go through and just check real quick, see if I can find a third one that matches that. So if it has the same a value, it's in direct variation together. So I'm checking through. How about that one right there? Right there. 120 divided by 60, that's definitely 2. So there I go, I found my 3 points that are in direct variation together. We've got 3, 6. We've got 6, 12. And we've got 60, 120. Now let's check for my constant of variation for inverse variation. So I get to say x times y. So my first one there says 3 times 6, that's 18. My next one says 7 times 15, which is 75. My next one says 6 times 12, so that's 72. None of these are matching up yet. Let's hope there's one coming up soon. And I see 1 times 24, so that's a 24. Still nothing. 60 times 120, that's 7,200. That one's way off. My next one says 4 times 6. Hey, there's a 24. And my last one, 2 times 12. There's another 24 as well. So I see my 3 points right here. So my constant of variation is 24 for each of those, so they are an inverse variation together. So that was 1 and 24, 4 and 6, and 2 and 12. Another thing that I need you to do for direct variation is graph them. Now you don't have to graph inverse variation, they're curves. We don't get to curves till algebra 2, but I do need you to graph these lines. So these are direct variation, which means they always go through the origin. That's a very important part of these. So the first thing, they need to be solved for y. I'm going to take these and I'm going to divide by that 2. So it says y equals 3x. My y-intercept we always know is 0 because it begins right here. My slope comes in front of my x. It's 3. But a better way of writing slope is as a fraction, so we say 3 over 1. And my constant of variation is the same thing as my slope, so I get to say 3 over 1 again. So I go to my beginning point, the origin, and I go up 3 over 1 because that is rise over run. So up 3 over 1, up 3 over 1. And now I can just connect the dots to form that nice line. I'm going to label that number 12 since I'm putting another graph on this coordinate plane. For 13, I've got an x on the wrong side and I've got this negative on my y. So let me get rid of the 1x right here, put my ninja in. I'm going to put my ninja in on my y as well. So when I switch the side, I switch the sign. So I have negative 1y equals negative 1x. And then I can divide by my coefficient of that negative 1 right there. So I see y equals a negative over a negative is a positive. So I'm going to write that as positive 1x. My y-intercept, it's direct variation. It's always that plus 0 that we never really write. So I've got 0. It's going to start at the origin then. My slope comes in front of my x, and we should write it as a fraction, so over 1. And my constant of variation is the same as my slope. So this one's going to go up 1 over 1, up 1 over 1, up 1 over 1. And we'll label that one number 13 because that was number 13. For our next section, we're in scientific notation. The first one I want to write in scientific notation. So when it's a decimal, you're going to follow along until you come to one actual digit. So something other than 0. You're going to put your decimal point, your new decimal point, right behind that one digit. Now you're just going to write everything except the zeros. Unless that was maybe 2.03, then you would want to write the 0. And then you're going to say times 10 to the negative exponent because it's a small number. And we need to count how many hops from this decimal point to this decimal point. So we have 1, 2, 3, 4, 5. So to the negative fifth. Then on 15, we want to do the opposite because it says standard form. That's another way of saying longhand, so write it as long as possible. So I'm going to start with my 9.3, and I need to hop that decimal point to the right 7 places. I know it's to the right because that's going to make the number bigger, and my positive exponents make the numbers bigger. So I'm going to say 1, 2, 3, 4, 5, 6, 7. which means I need to add 6 zeros to this number. So we have 93, 0, 0, 0, 0, 0, 0. And then to make this absolutely right, we should put in our commas every third digit. Number 16 says, find the product. That means multiply. Now I use that word product because you'll probably see some word problems where I use the word product, or I use the word quotient, or I could even use the word sum or difference. Oops, I skipped number 16. Apologize. Let's go back to that one. Number 16 says, order the following from least to greatest. The smaller the exponent, the smaller it is, the bigger it is, the bigger it is. Negative numbers, remember, always work the other way. A bigger negative means the smaller it is. So I'm going to go right here and start with 8.9 times 10 to the negative 11th. That is my smallest number. My next smallest is the next smallest exponent. So 4.9 times 10 to the negative 1. Now I've got two exponents of 7, positive 7 here. So when you have the same exponent, we're going to have to go back to its base up here. This one says 1.5, this one says 1.2. 1.2 is smaller, so we're going to go with that one next. And then we'll go with the bigger one. So 1.2 times 10 to the 7th. And then 1.5 times 10 to the 7th.